So we get this situation. We have to integrate 2x minus 1 cos root over 2x minus 1 whole square plus 5 upon root over 4x square minus 4x plus 6. Okay. So if you'll observe this question, you may find that this argument is annoying. Also you can say that sir, denominator is also under root. So I feel that both to be annoying. Okay. So first let's simplify the question. First we will break down the square root of numerator's part. Okay. So it is 2x minus 1 cos. Now it is 4x square plus 1 minus 4x plus 5. Now look at this. Don't you think that the denominator and numerator comes out to be same? Okay. Root over 4x square minus 4x plus 6. Now what you have to do, you have to take, both are ugly and both are same. So what I'll do, I'll take that thing as z. So root over 4x square minus 4x plus 6. I will take this whole thing as z. So let's differentiate dz by dx. You know that the differentiation of root x is 1 by 2 root x. 1 by 2 root x. Root 4x square minus 4x plus 6. Now we have to differentiate the thing which is available in the inside root. Okay. So 4x square differentiation will become 8x and differentiation of minus 4x becomes minus 4. You can take 2 common, you can take 4 common. Okay. So if we will take 4 common, we will be left with 2x minus 1. Okay. So it is 2x minus 1 with 2 times root over 4x square minus 4x plus 6. Let's do the simplification. Now look at this. We have this entity, we have dx and we have the denominator thing. So can I apply the replacements as dz by 2 equals 2x minus 1 upon root over 4x square minus 4x plus 6 and then dx. So we will apply whole replacements and we will be left with cos z dz. Okay, with 1 by 2. Correct. Now you know that the integration of cos x is sin x. So it is sin z plus integration constant c. Now replace this z. So sin, who is z? Z is root over 4x square minus 4x plus 6 and then integration constant c. So the integration of the given integrand is this. I hope the idea is clear and you can handle similar situations. Okay.